Here's example 4, and let's go and add the arrows again. Now for this one, as you can see, it's not a parabola and it's not a V shape, okay? It's a polynomial. So for this one, we are going to say the vertex is none because it's not the highest of the highest or the lowest of the lowest, so there's no vertex for the polynomial. Since we have arrows going up and arrows going down, indicate that there will be higher values or lower values. We do have a couple of x-intercept, 3 to be exact. So that's 1, so that's going to be a negative, this is negative 1 right here. So let's see. So each one is a 0.2, so 0.2, 0.4, 0.6, 0.8, and then negative 1. So negative 0.4, so negative 0.4 comma 0, that is the first x-intercept. The second one is right there at 1 comma 0, and the third, that's 1.2, 1.4. Let's just approximate that to 1.425, comma 1.425. I'm just guessing on that one, okay? And you can eyeball that too if you want. The domain, the arrows on the right and the arrow goes on the left, that means it's going to be all reals. Or write it in interval notation. All reals in interval notation is going to be negative infinity to infinity. The increasing is going to be difficult for this one, so I'm going to hold on to that and do that last. The rate of change, since it is not a line or an absolute value function, we are going to write varies for now. We can find the minimum value. So the minimum value is that guy right there. So what is that value? Let's guess that out too. Let's see, 0.2, 0.4, negative 0.6, negative 0.8. So let's say negative 0.9. Minimum value is negative 0.9, okay? Or you can write negative 0.9 if you want. Maximum value is this one right here. So 1's right here, 1.2, 1.4, 1.6. Let's round that to 1.6, okay? So maximum value is 1.6. Is it a 1-to-1? Definitely not. Look at this. It doesn't pass that horizontal line test. So that's like 3 places. So no. Again, I'm going to hold on the decreasing function. Let's talk about the range because that's easier. The arrow right here indicates it's going to go up and down forever. So the range is reals, or interval notation said we should write it from negative infinity to infinity. Now there is a y-intercept right there at 1. So y-intercept is 0, 1. Axis of symmetry, none. So because axis of symmetry, there's not a line that we can write that would make 2 equal parts. Now increase and decrease. Remember, we talk about increases. Can I hike up somewhere? So the max and min is usually the break, okay? So over here, I could hike here, students. How do I? Okay, so this is hiking. So all this right here is hiking, and all this right here is hiking. So there are 2 increasing interval notation. The smallest x over here is negative infinity, and it takes a little break right here at that x value. And that x value, remember each box is a 0.2, so that's a 0.4. So that's 1 increasing interval. Then it picks up again right here. I'm going to show you. This is 1, this is 1.2. Let's say 1.3, okay, right here. So it picks up again at 1.3, and it increases again to infinity. Remember, we are using x values when we write increasing and decreasing interval, and there are 2 of them. Negative infinity to 0.4. We can technically spell out the word or, but in mathematics, students, let me write it right here. So in mathematics, you're going to see in our textbook, we don't have a textbook, they use this symbol U to represent or in math, okay? This right here is really fancy in math, symbol for or. And so or 1.3 to infinity. There are 2 increasing infinity. Now there's 1 decreasing infinity. You know what? I do love to draw out my sliding. Okay. Whee! Yeah, I can slide down this entire way. Okay. So again, the max and min location usually breaks off the increase and decrease. Now that maximum location is again at an x value of 0.4 And this minimum is 1.3. So the decreasing is from 0.4 comma all the way to the x value of 1.3.